Learning outcomes. After studying this module, you shall be able to know some important instruments and techniques used in forensic science. You will learn the fundamental principles of some important techniques. You will also able to understand working of some instruments which are used in forensic science investigation. Introduction. Solving mysteries is a challenge lots of individuals would appreciate if scientific approach is taken. They are expected to be used by forensic scientists to examine evidence and to solve crimes. Forensic scientists use the similar instruments and techniques used by academic scientists performing other kinds of research. It is essential that the forensic scientist must be aware of various sources of information and possess understanding of various tools and techniques that can give deeper understanding of the diverse fields of forensic science and the problems that are unique to these fields. Forensic laboratories that offer multidisciplinary facilities are commonly allocated into sections based upon the types of physical evidences which are examined. Some of these sections require specialized equipment, instrumentation and trainings of person, while other sections may share instrumentation. Like we have Question Document Division, in which we use video spectral comparator, which is also commonly called as VSC, comparison and differentiation of ink by evaluating the infrared reflection and luminescence qualities inherent to the ink, most frequently accomplished using a device known as video spectral comparator, which is, as I told, VSC. Video spectral comparator is a modern and advanced equipment used for document examination. VSC is a multi-purpose instrument which allows non-destructive examination of the document, exhausting multiple instrumental parameters and delivers prompt result with stress-free use. The VSC is an imaging device which allows an examiner to analyze ink or visualize hidden security features and reveal alterations on a document. VSC works on the basic principle of light. Different light arrangements and filters arrangement make it more powerful than any other equipment, having only light source of different wavelength. This equipment is a computer compatible. Data of the case examination can be stored and retrieved whenever needed. The instrument is applied or equipped with the specialized lighting tools for examination of document. The visible, infrared, ultraviolet, transmitted, coaxial and oblique lighting condition may be used alone or in the combination. The instrument allows observing and record the observation of a documents or a inks on exposure of light of different wavelength. This is useful for examination and comparison of ink. The examination of security feature in document such as passport and driving license, and the examination of changed or destroyed records, as well as the inspection of entries which have faded or been washed out. All this can be done using this particular instrument. It also permits the analysis of comparison of ink, revealing alterations of a document. It makes visible security features produced on the paper and permits a quick examination of the entire question document. Next device in question document field, we have electrostatic detection apparatus. Electrostatic detection apparatus, which is commonly called ESDA, is a special instrument capable of restoring handwritten impression in a paper that are completely invisible to the bare eye. Electrostatic detection apparatus, or popularly known as ESDA, is a device primarily used to detect indented writing on the document that can also be used to detect footwear impression on paper items. Indented writings are those which are created due to pressure on the paper, which are not visible with the naked eye, but they are present as the fiber on the paper get disturbed by the pressure applied on the writing instrument as well as on the writing pressure during the writing. It will be present on the paper on which writing is present below that particular paper. It is electrostatic detection apparatus used for decipherment of indented writings. The surface of paper causes a different pattern of charging in those areas where there are indentations. These charge variance is visualized by spreading over an oppositely charged black toner powder. The document to be examined is positioned on the instrument and covered with a sheet of transparent film. The film and cramped document are then exposed to electrostatic charge. The charge dissipates rapidly, excluding those areas where indentation are present. The ultimate stage comprises put on black toner to the exterior of the film, which stick to the charged parts, making visible the indented writing evident. The examination of document for indented handwritten impressions can be important for many reasons. This technique can yield a record information from papers that have been misplaced, destroyed, or no longer available. The next instrument we have stereosome microscope. The stereoscopic microscope is an optical microscope arrangement designed or low magnification observation of a sample, characteristically using light reflected from surface of an object rather than transmitted through it. The instrument uses two separate optical paths with two objective and an eyepiece to offer slightly different viewing angles to the right and the left eye. This arrangement produces three-dimensional visualization of sample being examined. Stereomicroscopy corresponds macrophotography for examining solid samples and complex surfaces topography and recording, where a three-dimensional observation is required for examining the details. They are therefore widely used in industries for production, assessment, and quality control. Stereomicroscope is an instrument or very important tool in entomology and forensic ballistics. The stereomicroscope should not be confused with a compound microscope equipped with double eyepiece and binocular. In such a microscope, both eye observes the same image with two eyepiece, serving to provide greater observing comfort. However, the image in such a microscope is no different from that obtained with a single monocular eyepiece. Now let us move on physical division. In physical division, we have refractometer. Glass as a physical evidence is repeatedly encountered in a number of crimes such as housebreak, traffic collisions, homicides, sexual assaults, gunfire incidents, arson and vandalism. Glass forms one of the evidentiary material in many criminal cases. The flakes of broken glass window panes may be loaded in a suspect's garment or shoes during the act of burglary or a crime. Particles of headlight glass found at the crime scene may offer indication that confirms the identity of a suspected vehicle. A forensic glass examination is typically a comparison of two or more fragments in an attempt to determine that both pieces of glass are originated from different sources. Less frequently, it is a question determined of end use or glass provenance. Glass examination are commonly conducted by refractive index measurements by the application of refractometers. A refractometer is a laboratory or field device for the measurement of an index of refraction. Then, in the division of physics, we have scanning electron microscope. Scanning electron microscope, popularly known as SEM, that is SEM, is used for observation of specimen surfaces. When the specimen is irradiated with a fine electron beam, the secondary electrons are emitted from the specimen surface. The topography of the surface can be observed by two-dimensional scanning of the electron beam over the surface and acquisition of an image from the detected secondary electrons. The scan electronic microscopes requires an electron optical system to produce an electron probe, a specimen stage to place the specimen, a secondary electron detector to collect secondary electron, an image display unit and an operation system to perform the various operations. The electron optical system consists of an electron gun, a condenser lens and an objective lens to produce an electron probe, a scanning coil to scan the electron probe and other components. The electron optical system present, which is inside of the microscope column, and the space surrounding the specimen are kept at vacuum. Then we have the differential thermal analysis. It consists of measuring changes in heat content as function of difference of temperature between the sample under investigation and a thermally inert reference compound as two materials are heated at elevated temperature or cooled to subnormal temperature at predetermined rates. In this manner, enthalpy changes such as melting, vaporization, crystallographic phase transition or chemical changes are detected from endo and exothermic bands and peaks that appears on the thermograms. The corresponding changes in a weight is determined by thermogravimetric analysis. Complete thermoanalytical data are obtained only by utilizing both methods of analysis. The information obtained coupled with X-ray diffraction, optical and chemical analysis of the residues and any involved gases provide a quantitative estimation of a solid state reaction. Next we have the sound spectrograph. A spectrograph is an instrument that separates incoming light according to its wavelength and records the resulting spectrum in some detector. The sound spectrograph, an automatic sound wave analyzer, is used for analysis and classification of human speech sound and in analysis and treatment of speech and hearing disorders. The analog sound spectrograph samples energy levels in a small frequency range from a magnetic tape recording and marks those energy levels on the electrically sensitive paper. This instrument then analyzes the next small frequency range and samples and marks the energy level at that point. This process is repeated until the entire desired frequency range is analyzed for that portion of recording. The finished product is known as spectrograph. It is a graphic depiction of the patterns in the forms of bars or formats of the acoustical events during the time frame analyzed. Next division we have Ballistics and Explosives Division. In this we have Integrated Ballistic Identification System, which is very famous to be IBIS. This IBIS is used for acquisition, storage and comparison of digital images from projectiles and cartridges cases. The system is a screening tool that facilitates the laboratory to characterize local, national and international relationship that may exist amongst firearm cases surrender for inspection. From side-to-side application of computers and an improved microscope, An operator can compare previously recorded images to new evidence received. Imaging of a projectile and cartridge cases are digitally taken and uploaded for comparison. Next we have neutron activation analysis of GSR, that is NAA. It is generally termed for irradiating material with neutrons to create radionuclide. Neutron activation analysis was discovered in 1936 when Hevesi and Levy revealed that samples comprising certain uncommon earth elements become extremely radioactive after its exposure to a source of neutron. From this scrutiny, the rapidly predicted probable of engaging nuclear reactions on the sample trailed by capacity of the induced radioactive to facilitate both qualitative and quantitative identification of many elements. Then we have comparison microscope. A comparison microscope is a device used to analyze side-by-side specimen. It contains two microscopes linked by an optical bridge, which outcomes in a divided view window, enabling two separated objects to be viewed simultaneously. Comparison microscope is essentially two microscopes linked to an optical bridge that permits the observer to detect two objects concurrently with the same grade of magnification. This instrument can have monocular or binocular eyepiece. Now let's move to the ballistics chronograph. Chronograph is an instrument used for recording graphically the movement or duration of an event, measuring the intervals of time. The ballistic chronograph measures and displays the velocity of projectile passing through it. The device infers the activation of internal sensors caused by passing projectile as time-stamped events. Subsequently, all the sensors are activated. The precursor does some calculation with the timestamps and shows the velocity measurements. Most chronographs operates in an ambient light and the shadow of the projectile. This dependence on the ambient condition creates a source of error for measurement. The chronograph built for this project is not dependent on ambient light condition, so measurements are more repeatable. Next we have energy dispersive X-ray fluorescence, that is XRF. XRF is a non-destructive analytical technique used to determine the elemental composition of the material. X-ray technique based on the emission of characteristic X-ray radiation when a sample is exposed to exciting radiation from more energetic X-ray. The spectra displaced and intensity varies energy or wavelength. Now let us move to Fingerprints Division. Here we have Automated Fingerprint Identification System, that is FIS. FIS is primarily used by forensic scientists for criminal investigation. The assembly of physical evidence at a crime scene will be useless if such evidence cannot be properly handled and analyzed. Since fingerprints are most often recovered physical evidence, constructing the system of investigating such prints contribute the maximum towards greater success in identifying criminal offender through the use of physical evidence. Automated fingerprint identification system enables computer to make rapid and accurate comparison between the fingerprints and the vast number of fingerprints in police records. FIS is a biometric system usually used in law enforcement where groups of prints improved in the crime scene were linked against the database of recognized and unidentified prints. Next we have polylight. A polylight source is made up of powerful lamp containing the ultraviolet, visible and infrared components of light. It then screens down the light into separate color bands that improve the imaging of evidence by light interference technique. comprising fluorescence, that is the evidence glow, absorption, that is the evidence darkness, and oblique lighting, which is the small particle evidence exposed. The use of fluorescent improvement procedure that trace a light source significantly upsurges the kind of planes from which a latent fingerprint can be identified. Now let us summarize this module. Forensic scientists use the similar instrument and technique used by scientists performing other kinds of research. It is essential that the forensic scientist must be aware of the various sources of information and possesses the understanding of various tools and techniques that can give deeper understanding of the diverse fields of the forensic science and the problem that are unique to these fields. A comparison microscope is a device used to analyze side-by-side specimen. It contains two microscopes linked by optical bridge which outcomes in a divided view window, enabling two separate objects to be viewed simultaneously. Chronograph is an instrument used for recording graphically the movement or duration of an event, measuring intervals of a time. The ballistic chronograph measures and displays the velocity of a projectile passing through it. XRF is a non-destructive analytical technique used to determine the elemental composition of the material. FS is primarily used by forensic scientists for criminal identification. The assembly of physical evidence at a crime scene will be useless if such evidence cannot be properly handled and analyzed. A polylight source is made up of powerful lamp containing the ultraviolet, visible and infrared components of light. Thank you.